Hi everyone, I'm going to walk you through how to do the enrichment multiplication of a fraction and a whole number. You have two templates in your packet this week. One of them, the word problem, is provided to you, and then you have to show that word problem as an addition problem, a multiplication problem, a model, and show it on a number line. On the second template, you are not given the word problem, you create your own and then show it each of those ways. So I am going to do the problem that is done for you. I'm going to walk you through it. You're welcome to follow right along with me, just like we were in class. That way you know how to work out each of these when you create your own. All right, so I'm going to go ahead and flip my camera so you can follow along. Here we go. The problem reads, Greg ran 2/3 of a mile each day for 4 days. How many miles did he run? When I think about this problem, I like to think about it going from the addition problem to the multiplication problem to the model and then finally on the number line. Because that's just the way I understand it best, and I'll explain that as we go. So if we're looking at the addition problem, let's start there. Well, I think about this in days of the week. So I'm going to go, here's Monday, and I know that each day he ran 2/3 of a mile. So on Monday, Greg ran 2/3 of a mile. On Tuesday, the second day, he also ran 2/3 of a mile. On Wednesday, he ran 2/3 of a mile. And on Thursday, Greg ran 2/3 of a mile. So now that I'm looking at this, I can see that what I have here is actually a repeated addition problem, and to solve it, I just need to add each day together. When you're adding fractions with like denominators, don't add the denominators together. The denominator stays the same. All you do is add your numerators. So 2, 4, 6, 8. So 2/3 plus 2/3 plus 2/3 equals 8/3. That is an improper fraction, but we will get to how to turn that into a mixed number shortly. So for right now, our answer is 8/3. Okay. Now we know, and you guys already know, that repeated addition is the same thing as multiplication. Okay. So since we know that, we should be able to then take what we did here and apply it to a multiplication problem. I'm going to take my fraction 2/3, and I'm going to multiply it by the whole number 4, just like that. Okay, how do I show how to work this out? Well, I also know that when I multiply fractions, I can multiply straight across. So what I'm going to do to give myself a denominator here is just add a 1 under the 4. Why can I do that? Because this 1 does not change the value of my 4. Then I can go ahead and just multiply my numerators straight across. So I'm multiplying 2 times 4, and here I'm multiplying 3 times 1. Okay. 2 times 4 equals 8 in my numerator. 3 times 1 equals 3 in my denominator. And you can see I got the same answer in my multiplication as I did when I did my repeated addition. It's the same answer. So you can see how I took the repeated addition and applied it to multiplication. Now we're going to take what we know about multiplication and we're going to apply it to our model. Okay. This model is going to look a little different than models than we've done before, because we need to show each day in a model. So before we've drawn one model to show our whole, and this time we're going to draw 4 of them, because each model is going to represent one day. So here's, let's say this is going to be my Monday model. Here's Monday. Here's Tuesday, and pretend these are all the same size. Here's Wednesday. And here is Thursday. I'm going to divide each of these models into thirds. I know that because that is the denominator in my fraction. So that's what I'm going to do first. Just divide each day into thirds. And then I'm going to shade in 2/3, the amount he ran for each day. So there's 1, 2 for Monday, and 2/3 for Tuesday, 2/3 for Wednesday, and 2/3 for Thursday. Okay, so you can see that now I have my model shown for each day that he ran. All I have to do to find my answer is to add up each of the shaded regions. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 shaded regions. And again, your denominator is not going to change. So even though I did it 4 times, it's still 8/3. Sorry for all the smudges. 8/3. Okay. Now the trickiest one, or what I think is the trickiest one, so I want to walk you guys through this one, is how we are going to show this on a number line. Okay? That's always the hardest one. And so now that we have worked out this answer 3 different ways, and we know without a doubt that our answer is 8/3. Before you do the number line, you're going to want to convert this 8/3 into a mixed number. So how do we do that? Well, 8/3. Let's write our fraction down. And first I'm going to convert it. So first I'm going to show you guys how to convert it. My denominator is going to become my dividend. That's the number on the outside of a division problem. So here's my dividend. My denominator is going to become my divisor, which is the number on the outside of my division problem. My numerator is going to become my dividend, which is the number on the inside. Then I can just work out this division problem like I normally would. I know that I can take 2 groups of 3 out of 8 without going over, so I subtract. 3 times 2 is 6, and I get a remainder of 2. Now I need to take all of these numbers and put them into a mixed number. Okay, so I'm going to color code this a little so you guys can kind of follow along. My whole number 2 out here, I'm going to put it in pink. This is going to become my 2 wholes. My remainder, I'm going to shade in orange. That's going to become my numerator, so 2 and 2. And my denominator is going to stay the same. It's still my divisor, it's going to be 3. So 2 and 2 thirds. Okay, so you can see how I got that as a mixed number. Why do you need to convert it before you put it on a number line? Because this is going to tell you how long you need your number line to be. I need my number line to go above 2 and 2/3. Okay, and so you go to the next whole number. What would the next whole number be? The next whole number would be 3. So my number line needs to start at 0, and it needs to go all the way to 3. So 0, and then divide it into thirds. 1, 2, 3. Just like we did here, each of these thirds needs to be divided into thirds as well. So 0/3 would represent, 0 would represent 0/3. Then you need a 1/3, 2/3, and here's 3/3, 4/3, 5/3, 2 would be the same as 6/3, 7/3, 8/3, and then 3 would be 9/3. So your number line needs to go all the way up to 9/3, to 3. Okay. Now we can show the jumps on our number line. Remember that we are doing 2/3 plus 2/3 plus 2/3, or 2/3 times 4, so 2/3 4 times. So I'm going to go 1, 2. So here's 2/3 1 time. So I jumped 2/3. I'm going to count 2/3 again. 1, 2. Here's my second jump. 2 times. And then I'm going to count 1, 2. Here's my next jump. So I've done 3 jumps, 1, 2, 3, and I need to do 4 total. So I need to go 2 more. 1, 2, 2/3. Okay, and this is where I land. So where did I land on my number line? Here's 6/3, 7/3, 8/3. So I landed at 8/3, and we know that's correct because we've already found that out in each of the other problems. So then on my number line, you can see I got to 8/3. Now this is tricky, and especially when you have to come up with your own problem. So practice it a couple times, okay? Just to show you guys, this is my 3rd attempt at this problem. I've done it 2 other times. It takes a little bit of practice. Okay, so here's my 2 other times before I finally did it all correctly. So don't worry about how many times you have to go through it or practice it. Practice it on a separate sheet of paper, on a scratch paper, before you do it on your own. If you have any questions, obviously, let me know. I'll be posting a picture of this as well to our Class Dojo and Remind page. But check out the video, follow along with me, and then use the other template to create your own. All right, I cannot wait to talk to you guys this week. Take care, stay safe, and I will see you soon.